May 1st, 2015, Gate Precast, Monroeville, Alabama. We're at the Big Beam Challenge that we are about to cast here with a group of students from the University of Alabama. We have Saga and Nathan and Drew that are going to be here today, and they're going to watch how we cast concrete and fill this beam for their challenge. We've been working together for several weeks, getting a mold prepared and getting things set up so that they can cast this, and hopefully we're all going to win the National Big Beam Challenge. We're about to start placing an 8,000 psi mix in the form for the Big Beam Challenge. We've got our wires and probes, our sensors in, all that's tied in and attached, so we are ready to go. He's taking a little bit of concrete and has taken out a little bit of concrete at the bottom of the bucket, and now he's casting in SCC, or self-consolidating concrete, and is working his way down the form. We're going to move and get a little bit different view. View is ready to go. Over here we've got our team of Andrew and Saga and Nathan that are here. They've done real good at trying to ask questions and figure out things of what they're doing. We just talked about, I was glad to see some younger people in the construction business. Good job, Kevin.
Hello and welcome. This is the day of our test for the PCI Big Beam Challenge. It is currently 10:50 on the morning of Thursday, May the 21st, 2015. The members of our team would include our advisor, Dr. Shri Yaletti, Nathan Clanky, Vidya Sagar, and myself, Drew Lansdale. And here you can see our setup that was cast by Gate Precast in Monroeville, Alabama. You can see our reaction frame, if I back up. We have the beam simply supported at both ends, and then point loaded at the middle. That point load is distributed to two point loads onto the beam that are 3 feet apart. We have an NDI setup right here that will be measuring deflection by looking at those nodes that you can see there. We have two DCDTs also measuring deflection. 2 strain gauges that are inside the concrete at the moment. Here's our pump. Here is our National Instruments data acquisition that's going to be taking the data from the DVDTs and strain gauges, DVDTs, and load cells. And we will be starting the test momentarily. What have I learned from the project? Well, if you take all the lessons that you learned in the classroom and just decide to design a beam using that, then when you hand your design over to the precaster, there's going to be a lot of subtleties in that design that are going to negatively affect the people in the precast yard, such as in our experience, when we had to cut out a lot of the right angles that were in our design because it makes it hard for formwork removal, and then also the inclusion of number 3 stirrup bars running along the top corners of the shear stirrups. And we didn't originally have those because the design said, oh, it would work without it, but practically they had to be there because they had to hold the shear stirrups in place during casting. I think this contest gave us a lot of experience that we'll be able to use going forward in our careers, so that we'll be able to make that connection between the design on the paper and how that design actually gets put into practice.
Adding to whatever Drew mentioned about the practical aspects of the design, there are so many things that we realized during the course of the testing. In the classroom, we always talk about inducing ductility in the beam and stuff like that for concrete. While they do give us an idea, it's always hard to picture what ductility actually means for concrete. But looking at the beam bend so much under that load, and being so small in size, it could take loads of that capacity, made us truly realize the workings of a prestressed concrete beam and what it really means for a beam to have ductility. And coming to the deflection values, we had a discrepancy in the predicted deflection values and the measured deflection values in the experimental testing. Having the test data in hands allowed us to go back and check why this happened. That was a very interesting design experience for us. We were able to recalculate the moment curvature diagrams, and from that we were able to justify or validate how that 3.3 inches was actually correct, plotting the curvature distribution along the length of the beam and getting the deflection values from it just gave us the value of 3.3 inches again, thus validating our method, but telling us that the material properties need not always be the way that you intend them to be.
Adding to what Drew and Visa said about the practicality of design, in class we just design whatever works, whatever is easiest for us to put on paper. We've never had to worry about how someone's going to build it and what they need to see and what the shapes need to be. So that was interesting to hear the precasters' notes on our design and how we should change it. And the tour of the precast plant was very interesting as well. They did a lot more architectural precast than beams. So it was interesting to see all the forms that they were using and how they can mimic any texture and any color, and how architects have the eye for millions and billions of colors and I have the eye for like 6. So that was interesting. And I think we learned a big lesson on curing concrete. You kind of talk about it in class, and everyone says cure your concrete, but you never fully grasp the how it helps your concrete, how curing helps, because we didn't cure our concrete once it got sent to us, and our strengths were lower than the design strength and what the precaster was getting. So I think we learned a big lesson there, that next time we do the project, we'll find a way to moist cure the beam itself.